Hi everyone, welcome to my YouTube channel, and welcome back for those who have already been here. And today we are going to uh, talk about something really important in JavaScript. But yeah, we will run this later. But first, let me show you guys something and ask you some questions. Um, so first, what do you guys are expecting from this code to run? Like, what is going to be displayed first? When you see this, I think most of you think that uh, the first thing that will be displayed is start, and then since the timeout has 0 milliseconds, so it's going to be displayed next, and then since the promise is also directly solved, it's going to be displayed next. Oh, sorry, promise. And then we have end at the end. Yeah, that's what most of people are going to think. So today we are going to talk about how uh, JavaScript executes things under the hood. So I have here like a visual representation of how JavaScript works under the hood. So we have kind of different stacks. We have here the call stack, web APIs, stack queue, micro task queue, and event loop. So to explain it, we will start with the call stack. So the call stack is just the main thread of JavaScript, kind of, if I can say that, if you guys can allow me to say that. The call stack is the main thread, and the APIs, the web APIs is the I wouldn't call it a thread, but let me say the pool that contains all the web APIs. Like web APIs are things that involve the browser, like when you fetch data, you put a set timeout, local storage, files, yeah, all of that. So when it involves the browser, like event listeners as well, when it involves the browser, it's in the web APIs. And we have task queue, micro task queue, event loop. So to explain those the last three ones, I will just give an example. Um, well, when you have like a web API, the like set timeout, for example, the callback function of set timeout is after the timeout, it's stored in the task queue. But for a promise, when you have a promise, the promise is directly stored in the microtask queue. So then the event loop is the the container, like the pool where the task queue and the microtask queue are kind of passed by before coming into the main threads, the call stack. So now you are probably wondering, like, how does that work? Why are they separated before going into the event loop and then going to the call stack? So the reason is because microtask queue are prioritized over task queues. So when you have a promise, the promise will be executed first before the web API, the function that is inside the web API. So for anything in the task queue to be executed, the micro task queue, the micro task queue has to be empty. So all the tasks that are in the micro task queue has to be to go into the event loop and yeah, the micro task queue has to be empty for any task queue to be executed. And then for anything in the event loop to be executed, the call stack also has to be empty. So when something comes in the event loop, it's kind of like the event loop checks if the call stack is empty, and then it sends uh, every task to be executed. And then once the task queue is empty, once the micro task queue is empty, now then task queues can be added to the event loop and then go also to be executed in the call stack. So um okay, the next thing that we are going to do is um, we're going to execute this so that you guys can understand. But now that I've explained how JavaScript run things under the hood, I think you guys can try to guess what is going to happen. But okay, let's try it together. So to start, let's gather like the processes that are going to be in these different containers or runtimes. I don't know. So for the console log start, it's going to be in the call stack because it's not a promise or something coming from a web API. But this is going to be in the call stack. And then the set timeout is a web API, so it's going to be in the web API, web APIs. But then after in the web APIs, after this delay, it's going straight into the task queue, also known as macro task queue. And then for this promise, it's going straight to the micro task queue. Yep. And finally, for the last console log, this is in the call stack. So now we can directly put what is going to be displayed first, like put the order of how the things are going to be executed. So the first thing, the top priority of the JavaScript runtime is the call stack. That means that start will be displayed first, and then end, because they're in the call stack, they can't wait for anything in the other uh, container, if I could say, the other pools. So, and then what is going to be executed next is the micro task queue, because the micro task queue has priority over the task queue. I think I explained it before. So you have to think of it like in a restaurant when you have VIPs that has priority. So when they came, even if they just came and then you made an order like 2 hours ago, they are going to get their orders before you, definitely, because they are VIPs. So micro tasks are VIPs, and tasks, simple tasks, are just average people in the restaurant. So it's the promise that is going to be executed first, and finally the timeout. So to explain this, when you have a set timeout, the set timeout first go into the web APIs, and then after the delay, the callback function goes in the task queue. But for the promise directly goes in the microtask queue. And for one, you're probably wondering, like, one of them has to go in the event loop, but which one has priority? Well, it's the microtask queue. For any task queue process to be executed, it waits for everything in the microtask queue to go into the event loop. Like for every process that are in the task queue to move to the event loop, it waits for every micro task queue to be in the event loop. So the micro task queue has to be empty so that the task queue can push the processes into the event loop. And then the event loops also wait for the call stack to be empty to send his things there. So that's why we have this process over this one. But if you guys don't believe me, let's just execute it and then see what is going to happen. Yep, that's pretty much how I predicted it by understanding the JavaScript runtime. Sorry, what is happening? Okay, so if you understand the JavaScript runtime, it can really help you optimize your code and really understand how your code are executed. It's very essential and yep, it's very important. And thanks for watching and see you on the next video. Don't forget to subscribe.